And okay, let's do Cameron. Okay, so we're going to start our presentation. So we want to thank you all for being here today to watch our presentation. We also want to thank our volunteer, Cameron. Just so you all know, I actually worked in a dental hygienist assistant for on and off for the past couple of years. And Cameron also works in a medical device lab. We know you might all be a little bit concerned about Cameron and his well-being, but not to worry. We actually, as Cameron may not know, he actually has a medical condition called Bruxism. So we're going to help him with that. And we're actually going to get you a presentation now.
Not off at all.
So Bruxism is a condition in which the patients clench or grind their teeth at night. This can be caused by stress, anxiety, depression, genetic predisposition to do so, or even environmental factors. This can be treated by fixing the teeth after they've been worn down, by behaviorally helping them to stop grinding and clenching, or by medication.
So some of the things on the market right now that are similar to what we've done are the sleep guard. It measures your muscle movements in the night, and it'll send a little audio to your mind. Another one, the University of Florida, is something very similar. They're thinking about using it for athletes as well, measuring the pressure when you're hit to tell if a concussion could occur. A couple of patents that are on the way as well. This is very similar. It's a mouth guard with an electronic device that can be connected to an audio device or some sort of thing to wake you up. And another similarity that's a different patent is one that's connected to your jaw that will be connected to a some sort of noise or alarm to wake you as well.
Okay, and then we go into our controller. If you guys are familiar with the Raspberry Pi, this is a Raspberry Pi. We're going to go into a little bit how our controller works, programming behind it, and the idea of kind of the goal behind this mouth guard. The first part of our mouth guard is our sensor. So in your normal block diagram here, you always have to have a sensor. This is the sensor. It's a force-sensitive resistor is the way this works. And then we go in and interpret that sensor. The sensor is interpreted by this reservoir we have up here with a capacitor, and it uses a timing function to be able to get a reading from that sensor. Thirdly, we go into our actual controller, which is the Raspberry Pi. It's actually just programmed in Python, so it's all stuff that we already know. It's just a little more, you just have to learn a couple packages that we can build in this class, but it's a lot of fun. And then our actual actuator is headphones, or it can be, since the Raspberry Pi here has Bluetooth, Wi-Fi, all that stuff, you can go to any Bluetooth headphones, Bluetooth speaker. We've got a Bluetooth speaker right here we're going to be playing to. It has a 3.5 millimeter audio jack out, so any kind of audio output you can think of would be an actuator for this kind of headphone, or this kind of controller. So if you guys can't see, this is the setup we've got here. This is our mouth guard. Our mouth guard changed a little bit yesterday. It's a little more like an actual mouth guard versus the yellow thing you see up there. Now, Cameron, do you suffer from headaches? Oh, horrible headaches, right?
You would not believe.
Yeah. How about is it side your jaw or like up here sore at all?
All the above.
All the time. See, we're gonna try and help Cameron's problem a little bit. So Cameron, this guy's gonna go inside your mouth. There's a groove for the top and bottom part, or top and bottom teeth there. It's gonna go right into the right side of your mouth.
You gonna put it in for me?
You can throw it in.
Oh,
You can throw it in. This is just for show mainly. Okay, does that feel reasonably comfortable? We're working on the size. The size is a little big right now. Okay, so you want to scoot just over just a little bit. Okay, now we're going to pull up the Raspberry Pi, and we're going to have Cameron do a little run for us. Get this guy pulled up for us. Did earlier. Okay, here's a Raspberry Pi. If you're not familiar with Raspberry Pi, there's lots of different operating systems you can use. This one's called Raspbian, which is, as you can see, is reasonably similar to Windows.
What did I get myself into?
And so this is just a regular Python script here. If we run this script, it gives us a nice little GUI. So here's our GUI that you can interface with this clean big thing. So initially, all right, so Cameron told you you're going to do an initial run. For this initial one, just leave it in your mouth, no really biting, no clenching at all, just let it get a minimum value. So we started that run, it's going to run for about 7 to 10 seconds and get a reading out for us. So while that's running, how long should we do the run? Just time's sake, let's do about 30 seconds, just so we can get a feel for this. We'll do a 30-second run, and then down here we have some sensitivities. Those are basically K values, K values for the controller. So Cameron, your minimum is a 70. Minimum is a 70, okay, so keep that number in mind. So let's do a 30-second run, so that's half a minute. For the two sensitivities down here, these are designed so that, let's say if you just started this treatment process and you're clenching super bad, at night you don't want to wake up every 5 minutes when you all of a sudden start clenching. You really only want to hit the high points. And so you can set the sensitivity to more of a high point, so only when you're really getting it pretty bad, like when you have a bad nightmare or something causes you to really start clenching, then it'll go off. So these are variable sensitivities you can set. So right now, let's just set some values I've played around with. I know that work well. Okay, Cameron, now we're going to do a maximum. So go ahead and start biting down. You're going to bite down pretty good for about 7 to 10 seconds here. You're going to get a little tired too. So
Yes,
okay, you're good.
How's that headache?
Getting worse.
I think that's the highest maximum we've had.
Yeah, so we'll give you just a second to breathe. We're going to get our Bluetooth. Let's see what it's on. I'll wake you up. Our Bluetooth hooked up here. Maybe we want.
Is the speaker on?
It is on. We'll try it again. There we go. All right, Cameron. Now it's going to give us a little reading here. It's going to tell us an activation minimum. So what I've said in here, activation level range 0.45. So what that means is that when Cameron reaches 45% between the minimum and the maximum, that's when music's going to start. It's your favorite song. I already said it. Don't worry. And so keep that in mind. It's going to give us a little, you can even look up here. On the right side, this is your Python shell. It's going to give us a readout of what Cameron is actually biting at that time. So go ahead and play with it for about 30 seconds here after I start it. And you can see how the volume changes with how much he clenches, and then it's going to cut off when he gets below that threshold.
Okay. One of our next guests, one of the warmest, and at the same time, one of the most dynamic personalities I've ever met. When you hear her, you understand why she is the world's greatest gospel singer.
Now,
One of our next guests, one of our next guests, one of our
and then go ahead and bite down again.
One of our next guests, one of the warmest, and at the same time, one of the most dynamic personalities I've ever met.
Then automatically after here, Cameron, this is what your volume and your force look like. So on the right is your force versus time graph. And then so this is basically your input, your U input, your force versus time. On the left you have the output, the volume that goes into your model. Thank you, Cameron. You go ahead and take that out. Give it to our dental assistant here, who has nice gloves and ready for that. so the problem with with our controller here is that the model's too complex. Cameron, do you sleep very well at night?
Well, after this, probably.
Probably better. My wife doesn't sleep very well at night, super light sleeper. So you can't really get a good model for, okay, this much volume is going to wake this person up or stop them from clenching. So you really have to do kind of an online process model versus getting a like a programmed Python model. So that's why we had Cameron help us with that. So this is just an example of one of our step tests for the force and actuators. This is similar to what you saw Cameron do. And that's a doublet test that you could do with different forces. In conclusion, our smart mouth guard is a very stable system. It's not really, we can't do a stability analysis on it because there is no empirical or no analytical model. However, it's very stable. Like you can't, I mean, can you think of a way that it would go unstable? It's going to blow out your speakers if you go really loud, maybe. But there's a maximum that's set within the program on that as well. Non-oscillatory, very fast response time. And then it's individually calibrated, so you can go from that GUI that you saw earlier. And if you really want to hit it hard and get every little nook and cranny when you're clenching, you can do that. If not, you can change the volume sensitivities that you like. Any questions you guys have about our project here?
So is the idea that you train your mouth to not clench by kicking really hard?
No, but so bruxism is mainly stress-fed. Women are actually 4 times more likely to get bruxism than men are because women are just more stressed out. Just nature. It's how it works, I suppose. And so it's a stress thing. My sister has it very, very bad, and that's what actually started this project. Is my sister has headaches. I had to withdraw from BYU, like horrible, because she stresses so bad, and that stress comes out with clenching. And you can stop it during the day. During the day, you can try and relax or different therapies, chiropractor appointments, that sort of thing. But at night, the night's the worst time because you can't stop it. It's a subconscious thing where you just start clenching, and you can never break the cycle because it's at night. And so that's the aim with this guy, is that you will, if you just started this, like I was saying, and you're clenching really bad, you can do all your best that you can during the day, and then at night you can set this guy to a pretty low sensitivity, so it's not going to wake you up all the time. But you can start to knock off some of the high points and really start breaking the cycle of bruxism and clenching at night.
Yeah, you can like wake up and like calm yourself down.
Yep.
And try and relax, and then hopefully over time feel okay.
Yeah, it is. Not yet. Hopefully, when it's actually used, you have a Bluetooth or something, you don't have a wire coming out of your mouth, like a choking hazard. But no, we haven't actually tried that far yet.
How do you make the sensor?
So the sensor is a force-resistant sensor. You guys can see in the middle. What actually happens is it's 2 leads that come up with wires to airway, and then there's a metal plate over the top of it. And so it's a force-resistant sensor. So you can change the resistance depending on how much force is applied to that and how many connections this metal plate makes between these 2 leads. So that's how the resistor works. Yeah, so then this is actually, if you look on the kingofrandom.com, it's called Proto Putty. It's basically just silicone. It's like silicone caulk with food color in it.
It depends on the kind of material that you use, and you put the force sensor inside the material. So it's cushions to your teeth, but the force sensor can also feel the